Good morning to everyone. We're starting a Monday morning, fourth week, Math 20, MJC, and we're doing a pre-algebra. And we'll start out with the music, Ernie. And what was the selection? Paul McCartney and Dance Tonight? No, don't dance tonight. You do mathematics tonight. Bad choice. Now, I guess he didn't have Do Math Tonight on the album. Not good. We have an exam coming up Thursday. So just remind you of that. And in terms of exams, blue books. So a blue book for the exam. That's the same as we did for our final in the Math 10. So make sure you get maybe a green book, but a blue book is in the vending machine. They're green in the store, the bookstore. And we are finishing up Chapter 2. You had 2-5 for homework. We spent a lot of time answering questions on those on Friday at the tutorial. And I think things went well. I gave you a quiz then. I have those quizzes graded, a lot of 100s, so that's good. And we have 2-6 to do today. And we have 3-1 and 3-2 we're covering tomorrow and the next day before the test on Thursday, followed by a tutorial on Friday with a quiz on Friday. Now, in terms of what we do, I don't really see any need to do a review per se in terms of what's going to be on the test, which is chapters 1, 2, and I'm thinking at least 3-1 minimally, and maybe 3-2. So you're going to have to stay right on top of things and study a couple of hours or so on Wednesday night prior to the test. So at this time, what I'd like to start is with questions that you may have had from 2-5. I got one or two, I guess maybe 3 pages from one effort from the computer. So these are going to be the computer problems, and I'd ask you if you'd had trouble with those, print them out, and we'd try to discuss them, and that's what we'll do. And Sandra has provided me some questions from there, and if you have questions that also need to be discussed, we'll do that. The word problems that we're going to work on in 2-6 should seem rather comfortable from the standpoint of what we did in Math 10, okay, because we're going to use a very similar idea. We're just going to learn 3 new formulas. Okay, so formulas you memorize, and they are the formulas, at least in terms of one of them, is a critical formula for algebra. So before we do that, Ernie, I'm going to go to the board behind me. I have some space over on the right side. What's right behind me at the moment is a problem from the stat class that I wanted to have available to you tomorrow, and it happens to be involved with graphing. And so if we can go to that problem for a moment, because you remember from what we did in the simple closed curve unit, where we plotted points. And so I just want you to get an idea of what's done. This problem that we did this morning would be in Math 70. Okay, so the beginning algebra, which is the next course. And I think you'll find that there's a lot of similarity between what we did in Math 10 and that. So let's go to the board directly behind me for the moment. And these values here represent an ordered pair, birth rate and life expectancy. So this happens to be for 10 countries of the world. And what was involved here was to take birth rates, and they go from 8.23 per 1,000. So these are births per 1,000 in the country. And go up to, a high in this case is 45.82, which is Afghanistan. The life expectancies that you see here start out, this is at birth now, for a woman. This would be at 44.39 years. That would be expected life expectancy at birth. And the low figure is 38.9 down here. That's under 40 years of age, life expectancy. And of course, the high one we have is at about 86, and notice it had a very low birth rate. And so what was done here is something that you're pretty much familiar with. You have a lot of children. For a woman, the life expectancy tends to be lower. So that's what's going on here. And so what was done is simply take these as ordered pairs, set up a coordinate system, just like we did in Math 10, and plot all these points. So the dots you see up here are the points that were plotted, and we tried to fit a straight line to those points. And then this work down here was getting the equation of that line. And that is what we're going to be doing in pre-algebra, in anticipation of algebra. So with that said, I'm going to go over to the space on the right side and look at one of these problems that Sandra provided me. And this really helps not having to state the problem verbally. This is 25.45, I guess is the way it's done. Yes. And the direction here was to simplify. Simplify is a phrase you're going to find in algebra a lot. And it's a very nice, easy phrase to say, and it can get you into a lot of work very easily. So we have a negative 7 to the second power, then a minus 5, then I have what appears to be a bracket, and then I have a 4, a minus 2, outside the parentheses with the 2 plus 6 inside the parentheses and closed bracket. What is our order of operation? Go to the groupings first, the brackets. So if I look at this, I could simplify what I have in there and rewrite all of this. I would be inclined, just to save a little bit of time, since the exponent is immediately after the grouping, I would write that as 49, then a negative 5, and then go to the brackets. So I have a 4 minus 2, and then I have the 8 there, innermost parentheses. This 2 is indicating a multiplication. So if I look at what I have here, and I don't want to do this subtraction yet, because I have implied a multiplication here once I simplify this. So this is 4 minus 8, which is a minus 4. Make sense? How about negative 16? And I blew it. How about negative 12? That was my error. I saw the 8 and not the 2. So I have negative 16. I saw it once I looked at the monitor. 4 minus 16 is a negative 12. Does that feel better? Okay. Glad you're agreeing on that one. I don't know if this helps or not. Otherwise, I could have omitted this step. But this focuses on the fact this is going to become a positive 60. And I'm adding it to the 49. Where if you leave it as negative 5 times here, you may forget that its sign has changed. So I don't know if that is going to help or not, but we get a 60 here and then a 109. Does that answer the question? And most of the time, if you make mistakes here, it's the kind of mistake I just made, where you do, for some reason, you don't do the multiplication, and I saw the 4 and the 8 and said negative 4 and blew it. Then how do you check your answers? Sometimes it helps if you just try it a second time and see if you can get the same answer. You sometimes will make the same mistake. I probably, in retrospect, would have been better off if I'd done what in between. I didn't write the intermediate step and had written 4 minus 16. That probably would have avoided my error. Okay, let's see. In terms of the next one, this is 51. So 2, 5, 51. And I have a 9 squared. And again, this may not be the same problem you did. Likely not, because the computer generates a different problem each time. And then I have divided by a negative 7. I didn't make that division symbol very good. I think I've written that correctly now. This is in parentheses. I didn't pick that up. Now I think we're in business at this point. Okay, now what's your order of operation going to be? Exponents and radicals. So I would take the 81 first. Technically, it wouldn't hurt if I did this multiplication right there, but I think I'm going to isolate first on the radical and the exponent. These are perfect squares. So if you remember that 15 squared is 225 that we did as our shortcut. 15 squared is bigger than this number, and this ends in a 6. That means your last digit would have had to have been a 4 or a 6 to end in a 6. Well, 16 is more than 15, so that's not going to work. 14 is smaller, and it turns out this is a 14. Then I have minus 2, a division here, and a negative 7. Okay? That is where I kept thinking, okay, I'm in trouble because I'm going to end up with a fraction. There was a 21 there, and I didn't pick up on it when I wrote it. So this was a 21 here. Make a correction in your note. Now, what do I have to do? Multiplications and divisions in order given. Okay, so this is 81, and then I have a multiplication indicated. Then a plus 14. Then this is indicating what? Well, it's going to be, I would like to, I think, see that as plus negative 21 divided by negative 7. If I rewrite that step, I don't think I'm going to mess up the sign. Now, you can do it without that. But this is 81 minus 8 plus 14 plus 3. Now, getting that plus 3 is rather critical there. So at this point, I would, as a personal preference, add the positives together. So I have 81 and 14 is 95, plus 3 is 98. So 98 minus the 8 is going to give me 90, and that would be what I would prefer in terms of doing the problem. Okay, I could rewrite that as 98 plus a negative 8 if that is more appealing to you. That's what's meant. But whether you want to rewrite to that to get here, debatable. Again, enough that you don't make the errors, but if you get too much, it slows you down in a way that's not realistic. Now, those are two of them from Sandra's, and out of curiosity, where was it that you were having troubles?
I have no idea. I think on the 49.
Okay, backing up over to here, Ernie. Just slide over. Okay, on this one?
Like I would do the 16 and for the parentheses, I would multiply those together.
So when you had this one where you brought it down to 4 minus 16, you were multiplying those?
Yeah.
Whereas if you'd done this, might it have prevented that by rewriting it?
Right, exactly. And then the same thing with the 49 and the 5, so I wasn't sure if I was multiplying the 5 by the 16.
Okay, so when you get the 5 here, and you look at the negative 12, otherwise if I had that negative 5 out in front, I could have done the distributive property and had a negative 20, and then plus here would have been 80, and that would have become my 60 that is there. That's an alternative. But doing a distributive property is making things harder rather than easier, but it can be done. The key here, there's so many little steps, and to make one small error, you come back and you try to find it again, and the comment's been made by several people, just the length of time it's taking to do the problems. Okay, now, if I come back to this one, is there anything here that can give me some insights into what's happening on this one?
Just basically a step, just a small little,
Details?
yeah, it's just the little things that will mess me up, and just get off by a little bit or even off by a lot.
Okay, so what's being said, because I don't think the microphone's picking up, the little things that can get you off just enough to be wrong. And of course, on a test, this brings up the question. On a test itself, am I going to give partial credit? And the answer is yes. If I can see where the little error is and that everything else was okay, I will try to give partial credit. The other thing to keep in mind, this set's a very long set. It's a very demanding set, correct? Not all the problems in the test are going to be like that. You think of the quiz problems I gave. Those were much simpler, correct? And yet they're very representative of 2-1, 2-2, 2-3, 2-4. So how many of these hard ones are going to be there? At most 2. So if we look at number of sections where I'm going to have somewhere 20 to 25 questions maximum on the test in an hour's period, and thinking of how many sections we've done, where we might have 10 to 11, 12 sections involved from the 2 chapters plus 3, I'm only going to have about 2 problems per section. And so that means you aren't going to get a lot of these. Don't spend all your time reviewing these problems. Instead, make sure that you've done the easier problems. What was surprising is how easy it was to make mistakes in the quiz. Okay? And I'll try to get that out to you, but those were easier problems by far. You have to be careful you don't put all your time here. Now, are there any other questions from anybody else on 2.5? Okay, Robert? Did you happen to write down the problems in the computer so I could spend... Okay, am I going to need the other board? Oh boy. Okay, Ernie, I've been told that this is not going to be a nice one, so we're going to go to the other board. So I'll let you bring camera 1 over here, bring the other camera over, and we'll try doing that. Okay. Just wait for Ernie to get this camera changed. Okay, I'll leave this on the board in case we need to come back to it. And let's see what we have on this one. So, Robert, are you ready to read me the problem? Okay, fire away. Embraces. Let's go to the sideboard now. Absolute value. Negative 14. Still absolute value? Okay, so open parentheses. Negative 6. Close parentheses. Minus 75. Okay. Plus 7. Closed braces. Okay. Divided by 2. Open bracket. Negative 8. Square root of 36. Like that? Oh, I like that. I like that. You had it also. Okay. So much for randomization. Exactly the same numbers? Wow. Unusual. What am I going to do first? Well, obviously, if I'm going to stay in here, I'm going to go to these absolute value symbols. They work like brackets as far as what I'm doing, the grouping. And so inside there, if I just work with this, I have absolute value, and I have a multiplication in there, a negative 14 times a negative 6. So I do the multiplication first. Understood? And so that's going to give you an 84 and a minus 75, and that's going to go to a 9. So the absolute value of 9 giving me 9. That's still all in braces, correct? Then I have what? Plus 7, plus 7, plus 7. So I'm at a 16. Agreed so far? Then I'm going to divide by, I have a 2, and then I'm going to go inside and do the radical next. Question before I do that?
Yes. Okay, on the 9, whenever I read the definition of absolute...
Oh, it is the opposite if it's a negative. If I had a negative 9 in here, then it would be the opposite. But if it's a positive 9, the absolute value is just 9. Your absolute value can never be a negative number. We went through a number of examples of this on Friday night. If you didn't have a chance to be here on Friday, I would really encourage you to take time to watch the VHS tape that's over at the reserve desk. And you can do that for each of the tutorials. They're over there. And if you can't be here for that, that's at least one way of participating. So this is negative 8 plus 6, still to the third power. So inside first. So this is going to be divided by still a 2 in the outside, and then I must do what? I don't know if you want to write this as a separate step. It's probably the safest. So that's going to be divided by, and then I have 2 parentheses negative 8, which means I have a 16 divided by a negative 16, which is negative 1, and I'm done. Does that answer it, Robert? Did you find where you made the step?
No.
Do I have a problem there?
Are you supposed to go from 16 divided to 2? And it would be
Did I? Okay. What you're questioning is order of operations. Okay, let me get an eraser. I was thinking of doing this part first. I have, okay, divided by this quantity. Now, is it going to make, this has to be a negative 2, so I'm up to here. Let me rewrite this step, make sure I didn't get caught here. So what I have here is divided by 2 and times a negative 8. And since I didn't have, and what I was thinking was this, and I didn't have that, so I am in error. I was doing that as a bracket. What I should have done, what? Done the division and multiplication in order. So this is a 16 divided by 2. That is an 8. That then is multiplied by negative 8. I did not have that parentheses, bracket, or brace, so you are correct. It would be negative 64. Okay?
I got it, but it was just a really tough.
Yeah, it's a long process, and okay, one of the things I said to you, and I got trapped with it, breaking this up, this part, and then this part, and mentally I was saying, okay, I've got a negative 16 here, 16 divided by negative 16, but what would be necessary to think that that would have had to have been grouped this way. Brackets first. It was not there, so I should have done order of operations. Okay? So again, the order of operations, I had to divide that 2 first, because in order given, the only way what I'd done would have worked had this been in braces here, then I'd had to do that first before I did the division. It was not there, so we should have done the division first. You are correct. Okay? Now, what I need to do is get into 2.6 because of the time frame. Okay? So in 2.6, we just are going to have word problems. With what you've done in 10, I think you're going to find that these go reasonably well. The first one I want to do, or at least the first part, is to write a couple formulas. This is one that we've talked about before. If you're going down the highway at 50 miles an hour and you go 3 hours, you got 150 miles. One more time. If you're going down the highway at 50 miles per hour, that's a how much problem in essence. 50 miles per hour times 3 hours, and you get 150. Distance is equal to rate multiplied by time. Okay? Very typical problem where distance is d, and we say rate, how fast you're going, and then we multiply it by time if we were to do it as a verbal formula. And this is one that gets used in algebra for word problems as much as anything we do in algebra. Distance equals rate multiplied by time. If you're taking a course in electronics, although it might be done as R times I, and depending on whose course you're taking, you might be familiar with it, E equals IR. But this is voltage, current, and resistance. So the I stands for current, resistance, you're familiar when you have a wire that you've tried to run too much current through. It gets very hot. Okay, that's because of the resistance, and that's what causes a fuse to blow out. That's what causes light bulbs to go out. And you can have some real problems when you put too much current through too small a wire. This is called voltage. And you're familiar with this in terms of batteries, I suspect, the idea of a 12-volt, 6-volt battery. And these refer to electricity. The resistance is measured in ohms. There's a real nice note in your book referring to that. Current in terms of amperes. And the voltage in terms of volts. So 12 volts, 6 volts, and so on. You don't need to know that any more than you need to know that when I do this formula, that A stands for area, L stands for length, and W stands for width. In any of these formulas, if I just give you numbers, you're supposed to substitute and get values. So if I tell you that L is 8 and W is 5, then you know that this is going to give you, by substitution, 8 times 5, and we say 40. Now, you don't usually do this kind of problem without what? Units. So we say 8 feet, 5 feet, and so here we come out with feet squared. You didn't need to know that. You didn't need to draw a diagram. If I just gave you that information, you can solve the formula. Okay? In the same way that if I tell you that R is 50 and T is 3, you immediately say D is 50 times 3 for 150. What's not clear is what your units are. And so we typically in this problem say miles over hours. We multiply by hours. And I think you see then that this is 50 miles over 1 hour times 3 hours. That is dimensional analysis. How much unit? And so we come up with miles here. Okay. In the same way, I can give you a value for R. I can give you a value for I. And you can get V. So if I had I is 3 and the resistance R was 4, then V is going to be 3 times 4 for 12 volts. Again, you don't need to know what those represent. Okay, but you're familiar with the 3-amp fuse, for example. That's just the current that it'll take before it blows. Resistance is going to be measured again based on the diameter of a wire. Big wires for large loads, small wires for small loads. And if you don't have them matched correctly for a given voltage, you can get into trouble. For example, I had what's called a starter for a refrigerator in a trailer. So it's supposed to create a little arc when the gas goes on, light the pilot, and you should be then able to go ahead. The wire was too big. The voltage, of course, was based on the wire, and the voltage, the current, wasn't big enough for the problem to trigger the switch. They had to replace the wire, and then it worked. So it's that kind of relationship that we're talking about. So I'm going to leave that there on the board for a minute, and I'm going to come to the book on these two problems. So I'll go back to the document cam. And so as we look at that, in terms of 2/6, here's where the formula is given to you on page 144. And this is the usual presentation, D equals RT. Notice the R and T together. I'm on page 144. And this is the classic formulation, just like we said that if you're going to take base times rate, you get percentage. Same idea. What's interesting, if I come now to page 145, and we look at the problem, coming off there just a moment, Ernie, and I look at a problem where I have, in this case, the distance is 150 miles, and R is the rate I want, and the time was 3 hours. Notice the text does not use the units of measure. So technically this is miles here. This is time in hours. So if I divide both sides by 3, which is what you're supposed to do, your R is what we would call 50 miles per hour. Notice the units are not used there in the usual sense of the word. So if I look at that problem, and then I come over to the problem we did here, which is the same kind of problem, in one case, I'm giving you R and T, you get D. If we go back to the document cam, you are given D and T and going to get R. So coming back to this formula, if D is equal to RT, and this is one of the problems I ask in a quiz, could you solve for R? You divide both sides by T. So you divide here, and you can write a new formula in which R is equal to D over T. That's solving a formula for one of the letters, and that is what you would be expected to do in an algebra class from that formula. So you have two choices. You could substitute, as was done, going back to the document cam, substitution for 150 and for T, then solve for R, or I can come back to here and say, well, I have 150 here, I had 3 here, and immediately get my 50. Same solution, different approach.
Is this like when we were using the triangle and math?
Yes, good argument. It's like using the triangle we did for base rate and percentage to remember what is over what. But rather than the triangle, if I again come back to that formula where we said you have P is equal to base times rate, we said in the same way you can just divide both of these, okay, by B, and you get the formula R is equal to the part over the whole, which is what gives you a percent. It's the same argument. And I said this was the alternative to using the triangle. Okay? Let's go back to the document cam. So obviously you're going to have two different kinds of problems. You're going to have one problem where you go ahead and you're going to have to, in that problem, as you look here, okay, coming back to it, you're going to, in a computer, possibly find this kind of step given through where if you did what I just did on the sideboard, coming back to that, that might have been your documentation where you first solve for R. Both of them are valid. I hope you can do both, but it's certainly not a matter where what I did in the board will be expected in the computer solution. Coming back to V, I, and R, this is example 2 on page 143. You'll note again, much as I did in the board, you just have two values thrown in where this is minus 9 or negative 9 amperes and 20 for the resistance. And you might ask, well, wait a minute, how do I get a negative out of current? If you look at the typical car, you have a ground which is the negative terminal on the battery to the engine. Now, if you buy some British cars, they had a positive ground. So if you bought a Lucas system on like a, let's see, what would it be? An MG, for example. Lucas had a positive ground. So the current was going in an opposite direction. So if you want things to work, you have to make sure your positive and your negative are consistent with the grounding. So most of you without cars are familiar with putting batteries into anything from an MP3 player to a flashlight. You have to be careful where you put the plus and the negative, correct? And if you reverse it, basically you're forcing the current supposedly going the other direction, and the circuit will not work with the current going in the opposite direction. So if it's set up for a positive current, I will be positive. If it's set up for a negative current, I will be negative. It's just which direction your current is going through the wire. Well, in this case, as we look at it, okay, we find that in substitution we get a negative 180 volts related to the substitution. This was in ohms and this was in amperes, and we say the volts are going to be negative 180. Coming off there, if I come down to this problem at the bottom of the page, and I'm solving for r, which is what's being done here. Otherwise, I guess I'm solving for I with r at 40. It's back to that same question. Do you substitute first? Because you want I by itself. So if I go to the sideboard, coming back over there, when I want I by itself, what could I do as we slide over? What could I do with this formula to get I by itself? Divide both sides by r. So I can take that statement and say then that if v is equal to I times r, divide both sides by r, and get that v over r is equal to the little letter I. Now back to the document cam. If I had v is negative 120, then I would substitute this for negative 120, this for a 4, and get I at negative 30 by that substitution. Or, going back to the book, doing it in what's done in that solution. Now those two problems are very typical. There are only a very few problems you're going to be doing for homework in this section, but there's one more that's involved, which is a bit of an oversimplification, and you don't typically find this in an algebra class as much as you do a business math class. But this is the formula at the very top of the page where we have N equals R minus C. And so R stands for revenue, C stands for cost, and N is your net. Okay? Now this, as I say, is a bit of an oversimplification. So the argument here is if I have one item I sell for $20 and it costs $15, my net is going to be the 5. Now understand that net is not necessarily profit, because your cost involves what besides the product? Overhead. And that's rent, that's heating, that is employees. And so you have to be careful with the kind of way you look at this. So net, again, is just the difference between revenue and cost. And I hope you realize that our current economic problems are very much involved with this right now. Because if I think in terms of revenue when I can't sell something, so let's say I have a car at a dealership that as a cost was $20,000, and I want to sell it for $20,000. My net is 0. The only good thing is I no longer have the car on the lot. Now, if you look around at all the car dealers right now, and that includes going to the ports where the cars are shipped to, sitting on docks, and you go to the manufacturer in Detroit where you have just acre and acres of cars, the downside of that, there's no revenue coming in at all. And all I have is the bills. So if it's costing 20, but I've already invested that, and then I sell it for 20, at least I'm paying some bills. What kind of scenario are we getting into with much of the economy right now? It costs 20 and I have to reduce it to 10,000 in order to sell it, and so my net is a negative 10,000. And if I keep doing that, the cars are off the lot, but I haven't paid for their production costs, and then you go into bankruptcy or ask for bailout from the federal government. Okay? That's, in essence, exactly what we're talking about here. You can do it in the housing market the same way. If you paid $400,000 for a house, that's your cost. If you sell it for $200,000 because that's where the market's gone, that's your revenue. Your net is negative $200,000. Okay? And that, again, is precisely what's going on. The difference is, instead of taking the negative 200,000, what are people doing? Locking the door and leaving. and it goes into foreclosure. Okay? Or you go into bankruptcy. Those are your choices. So let's look at the kind of problem that's involved here as an example. Let me ask you this question for a moment. You're familiar with the issue right now with the large vehicles and getting a small vehicle. So you have an SUV that you might be able to sell for $10,000. And you can buy a Prius for maybe $25,000. And you look at your costs. And so the question is, are you ahead or not in the process if you just lost money on the SUV? This is the kind of problem that's going on here. So profit or loss, again, net profit loss, a little bit oversimplified. But here's what we have. Person puts $2,000 down in a car. I'm on page 142. And this is as good a problem as any to follow through. Monthly payments, $275 a month for 5 years. Okay? Now, I hope you know that your total cost now is going to be the $2,000 down plus your 5 years of payments at $275 per month. So you have to take your 60 times your 275 plus your 2,000. That's your total cost. In addition, look at the maintenance. $15,000 in routine maintenance. So after 6 years, you sell the car for $5,200. How much did it cost you to have the car, in essence? Do you have a net gain or a net loss? Okay, now whether you consider that a profit or not, debatable. Okay, coming down here for the solution. And the point is, this isn't going to be done in just one calculation. Here is your 60 payments at $275 each. Okay, so that's $16,500 plus your what? $2,000 you put down, and then you had to have oil changes, minor repairs. So your total was $20,000. Now you're going to what? At $20,000, that's your cost. You got selling this car, what? $5,200. You subtract off your $20,000 it cost you, so your net is what? $14,800 in the negative, in the hole. At the same time, do you really consider that a loss? As we come off there. Or is that just the cost it takes you to go around and do your business? So in 5 years, it costs you roughly $3,000 a year. Again, come back to the problem. At $14,800, that's nearly $15,000 negative. In a 5-year period, that would be roughly $3,000 a year, which is roughly $300 a month. What did not get included in this? The gasoline that you spent.
Registration.
And registration. True. Okay? But is that considered a loss? And the point being, when you look at some of these problems, if you had to pay for public transportation for those 5 years, and you did everything in public transportation, what would be your cost then? And the convenience of having the car. So there's a little bit superficiality to that problem, but the point is you have to look at the total cost. And by the way, for those of you who are thinking in terms of the SUV versus the small, lower priced operation, when you do that and you look at how much you gain. Otherwise, if you have a net loss of $14,000 selling your car right now, and you kept it for another 5 years, arguing that maybe you still have another couple $1,000 you pay in repairs or whatever, If you had to sell the car and make that loss and then pay what? Another $25,000, are you going to gain enough in mileage and such to make it really a payoff? And in most cases right now, over a 5-year period, the answer is no. You don't end up with a positive result at the end. 3 different problems, all done reading through the information, a formula involved. Let's look at some of the problems you're going to have assigned. So the problems that I chose out of this, there aren't very many. Here are the selections that you'll see when you go to the computer homework. 7, 9, 13, 15, 21, and 23. So you have 6 problems that you'll have to do for tonight. Now the argument is these problems take longer typically than what you did in, say, 2-1, 2-2, and 2-3, 2-4. To say that these problems can be done any longer than 2-5, debatable. If you spent 45 minutes on a problem in 2-5, then you're probably going to find these shorter. Okay, so, and as word problems, don't panic. Let's look at what we have here. So, as we look at the 7th problem, and keep in mind, I'm not allowing you to use a calculator, and they show a calculator indicated in this problem. I expect you not to use one. But notice you're putting $8,000 down when you buy a Buick, and by the way, the Buick Century, they're talking about maybe not having that much longer. 60 payments at $288. You spent, okay, in $950 in maintenance and repairs. 3 years after paying off the car, you sold it for $4,000. What was your net? And in this case, you can note you're going to lose about $15,000. That's what you're working toward. Now, the problem you see as you do the computerized, as we come off there, your numbers are going to be different, correct? I want to give you a caution here because sometimes on the computer, on these problems where I think you're getting a problem about a car, it won't be a car. It'll be a problem with revenue and cost, but it may not be a car problem. So I'm a little bit concerned that what I think you're going to see is represented by this problem. So as we go back to this problem, you'll note this is done exactly as the example in your book. You're going to have to take your 60 times your 288. You add that to $800 down, and then you add $950 into it. That is your total cost. Your revenue is $4,000, so you have the formula that I'm going to go over here on the side now, and this is where substitution after your formula. Remember the steps we did before. So we go to the side. Formula, substitution, and answer. Now the revenue is not hard here. It's what? The $4,000. That's what you sold it for. The cost is an aggregate of combining your down payment, okay, in addition to that, how much you paid over a 3-year period, plus routine maintenance for 3 years. So you have 3 things here. Your down payment, what do we call this? The monthly payment, and then maintenance. So you have to put all this together to subtract off to get your final net. Pretty straightforward. The only danger here is it may not look like that simplistic when you go to the computer, and I have no way of anticipating that. Okay, back to the document camera. So hopefully that one isn't going to cause trouble. And I will try, when we talk about the test, to restrict myself to the word problems to these 3 types. Very much in a similar way. Okay, the next one, and by the way, number 9 is a house that's done. Same idea. And by the way, it costs a lot more with houses. Your payments are more, your upkeep is more, And I'm not sure that they're actually looking at it totally incorrect in a correct way because you have taxes, okay, that aren't factored into this, just like your registration fees and such are not being factored into the car. But let's go to 15 and 21. So I'm coming down to 15. Okay, very straightforward problem. You have the voltage in a regular, let's see, voltage in electrical current measures, and it's measuring minus 220 volts. The resistance is 5 ohms. Find the current. It's just a division problem. Fairly straightforward. So coming off there, let's look at a problem involving distance. And this one is a little bit different than you driving your car. Okay, this is a space shuttle traveling about a rate. This is how fast some of you would maybe like to go if you've got a long distance, 17,060 miles per hour. Okay, and how far does the shuttle go in 3 hours? The only thing that's interesting there is it's a very big number, but fairly straightforward. If we go back to the side board there, this is a case where as we go to the side and we slide over to the distance, rate, and time to the left of the clock, a little bit further, Ernie, your formula, then substitution, then answer. 3-step process. Now you can get by with less than that in the computer perhaps, but on a test, I want the formula, the substitution, and the answer. Agreed? Okay, let's go back to the document count. Those are the 3 types of problems. You only have 6. I think you're going to find that this is more than enough. Well, you'll have more than enough time to do these. The computer's been set up, so this will time out tomorrow at 11, and I won't be adding more time to that because we need to go into 3.1 and 3.2. Now, let me make some comments about studying for an exam, because at this point, this is a fairly light assignment. What you need to do is a little bit what I am going to be doing as the following. And I watched Sarah as she did what she selected for a practice test on the computer. We both approach tests in the same way. We're going to look at each section and pick 2 or 3 problems. Here's what I suggest you do for getting ready for the exam starting tonight. Go through your text and try to find 2 medium level difficulty problems. Not the easiest, and don't find the hardest, but make sure they're different enough that they would be what you would write for a quiz problem. Take 2 from each section. Chapters 1, chapters 2. We've done all those sections now. Write those out for yourself. So you will have, since there are 6 sections here, 12 problems from here, 2 from each section. And if you look at the first chapter, that went up to, the last section there was what? Section, I'm trying to get to there beyond the reviews and the summaries, and it looks like my last section there was the 1 and 1/6 there. So there's 12 problems from there. That's 24 problems. So shoot for 24. 2 from each. Write them down. If you have time, try doing the problems so you can write an answer sheet. Then, make copies of it and start switching with each other, going through those problems in a review until you've done 3 of them. It'll take you about an hour each, but you've got 3 days. So you'd write it out tonight, switch with somebody tomorrow, try doing their selection, then go exactly the next day the same way, and by Thursday, you should have done a pretty good review. Ernie, as we close down,